Hi everyone, this is A Navin, rule number 49, and my topic is about MPEG digital video coding standards. Contents: Introduction, standardization process, MPEG family, H.266 family, VC1 standard, other popular video coding standards. Introduction to video coding standards. A video coding standard is a document describing a bitstream structure and a decoding method for video compression. The standard does not define the encoder, rather it defines the output structure that an encoder should produce. Video coding standards usually define a toolkit or a set of tools for compression. Video coding format, or sometimes video compression format, is a content representation format for shortage or transmission of digital video content, such as in a data file or a bitstream. Examples of video coding formats include MPEG2 Part 2, MPEG4 Part 2, H.264, MPEG4 Part 10, HEVC, Theora, etc. A specific software or hardware implementation capable of video compression and decompression to form a specific video coding format is called a video codec. Some video coding formats are documented by a detailed technical specification document known as video coding specifications, such as are written specifications. Some such specifications are written approved by standardization organization as technical standards and are known as a video coding standard. Why standardize? Standardization enables encoder and decoders from different manufacturers to work together across a range of applications. In order to provide the maximum flexibility and encourage innovation, the standards do not include all practical issues and design techniques of the decoding process. Standardization allows for decoding of a byte stream from previous and emerging standards. The standardization process. The main steps towards the finalization of a standard are shown below. Identification of requirements, development phase, selection of basic methods, collaboration phase, draft international standard, validation phase, and international standard. In the first phase, the requirements for a specific application or a field of applications are identified. In the next phase involves the development of different algorithms by various laboratories, companies, or contributors. The developed algorithms are compared and a set of basic techniques which forms the core of the standard is selected and refined in a joint effort during the collaboration phase. At the end of this phase, a draft standard is issued which has to be validated by compliances testing based on computer simulations or hardware tests and field trials. After successful validation and refinements, the final standard is published. The MPEG family of video coding standards. The IEC Motion Pictures Experts Group MPEG published standards from media coding, storage, and transport. These standards consist of different parts. Each part covers a certain aspect to the whole specification. MPEG-1, standardized in 1993, it is a standard for lossy compression of video and audio, developed for video and audio storage of CD, ROMs, digital cable, satellite, TV, and digital audio broadcasting. The best known part of the MPEG-1 standard is the MP3 audio format it is introduced. Supports YUV 4:2:0 at common intermediate format resolution. The standard consists of the following 5 parts: systems, storage and synchronization of video, audio, and other data together. Video, compressed video content, audio, compressed audio content, conformance testing, reference software. Here we see the hierarchical data structure in MPEG-1. MPEG-2 Part 2, standardized in 1995, supports video on DVDs, standards definitions TVs and high definition TVs. Can handle YUV 4:2:0 and YUV 4:2:2 formats. Supports interlaced and progressively scanned pictures. Introduction of profiles and levels to define various capabilities of the standard of subsets. For example, MPEG-2 main profile high level is suitable for high definition television HD TV. Scalable extensions which permit the division of continuous video signal into two or more coded bit streams representing the video at different resolutions, picture quality, that is SNR or picture rates. Other features include data partitioning, nonlinear quantization, VLC tables, and improved mismatch control. MPEG-4 Part 2 Visual standardized in 1999, supports video on low bitrate multimedia applications on mobile platforms and the internet. Supports object-based or content-based coding where the video scene is coded as a set of foreground and background objects. Supports coding of synthetic video and audio including animations. Shares subsets with H.263. Short header mode. MPEG-4 Part 10 Advanced video coding standardized in 2003. Co-published in H.264 AVC. The H.266 family of video coding standards. The following standards gives the key features of H.266 family. H.261 standardized in 1988, developed for video conferencing over ISDN. Support for CIF and QCIF. Resolution in YAV 4:4:2:0 format. Uses block-based hybrid coding with integer pixel motion compensation. H.262. Standardized as MPEG-2 Part 2 video in 1995. H.263 by H.263 plus. H.263 was introduced in 1996. H.263 plus was standardized in 1998. Improved quality compared to H.261 at lower bitrate to enable video conference telephony. Subpixel motion vectors up to 1/8 pixel accuracy for improved compression. Share subset with MPEG-4 Part 2. H.264 Advanced Video Coding standardized in 2003, supports video on the internet, computers, mobiles, and HD TVs. Significantly improved picture quality compared to H.263 at low bitrates, but at the cost of increased computation complexity and weighted prediction. Advantages: 2 times higher compression as comparing with H.264 AVC, reducing burden on global networks, minimize energy consumption to extend battery life, reduce the power consumption and cost, high efficiency, low complexity. Here we see the video compression, MPEG-2, MPEG-4, H.264, and in MPEG-2 we see the broadcast digital TV, DVD, Blu-ray, and MPEG-4 IPTV, and H.264 web video, mobile video. Here we see the process of video encoder and decoder. From MPEG-1 it will go to MPEG-2, and MPEG-1 is of 30 fps and MPEG-2 of 60 fps, and from MPEG-2 it will go to MPEG-3 and it is of 1080 fps, and from MPEG-3 it goes to MPEG-4 by H.264 and it is of 60 fps, and from H.264 it go to H.265 and it is of 300 fps. Here we see the salient features of H.264. Variable block size motion estimation, quarter pixel accuracy motion estimation, motion vectors over picture boundaries, multiple reference frame facility, integer transforms, directional spatial prediction for intra coding. And that's all about my topic. Thank you.